We're going to talk about recycling innovation. When I was advancing recycling many moons ago, as I've said earlier, I wanted to see a variety of different recycling forms take hold. And when we first wrote our recycling laws in California, for example, there was essentially no such thing as plastic recycling at all. Nothing was happening. Our rates were maybe 1 or 2% by mistake or something. I'm not sure how we ended up with it. But through that legislation, we managed to push plastic recycling rates for the plastics that were covered to 60, 70, 80%. And revolutionized the industry and really kind of force-pushed, if you will, the development of robust recycling system for certain resins out there. And now the costs have been radically reduced. I remember the first costs were $1,000 a ton. $1,000 a ton to recycle those plastics. And now they're under $100 a ton, I believe. So it's a radical enhancement. We're going to have to get there on a lot of other materials too, and we can if we allow the systems and the solutions that are out there to come into place and to evolve. And we have some experts who are going to tell us a little bit about how to do that here with us right now. I am going to go first to Sarah from the Recycling Partnership. Recycling Partnership for how many years? How many years now? 12 years. 12 years. Quite a remarkable. I don't know if I would describe it as a coalition or a partnership. Well, it is a partnership. I guess I can be pretty safe to say that word. Between major retail and consumer brand companies and environmentalists and recyclers to accelerate the recycling infrastructure across the country. How did that happen? What has been your success rate so far, and where are you going into the future? That's all.
Is this thing on? Oh, yes. Oh, my God. Yeah. Sorry, y'all. Hi. Nice to see all of you. All right, Bill, that was a loaded question of a lot.
I know, it was like, yeah.
I am the Vice President of Strategic Engagement, so I am the one that asks all those brands, CPGs in the room, many of you, for money. Mm-hmm. So one, thank you for being our partners. We really got started as an access organization. We saw this big gap needed in the system, and we realized we needed to de-risk it through things like grants, right? Yeah. We all know this system is very expensive, and communities are going to continue to fight over what they have to focus on. And it's really not fair, right? You've got roads that are breaking down. How do you justify those sort of things? And so we really came in as like a de-risker for access. And then through that, we saw sort of the whole system lens and saw where there was gaps at. And so started diving into each one of those gaps, whether that was for MRFs, not being able to take acceptable certain materials like polypropylene, PET thermoforms, and then all the way down to what we're really working on right now too is the demand side. So alongside policy. So really what we're trying to think about in demand is like, how do we make sure recycled content is required so that we have a place for that material to go? Mm-hmm. And you have a lot of experts on this panel and the people that go before me. So I just want to say I have worked in this industry my entire career. I know on the ground what is realistic, but I don't want to pretend to be a scientist today. Does that answer all your question?
It does, but what's your next big challenge? What's the next big challenge for the partnership and for the industry to make recycling work?
I think one of the biggest things we're really focused on is consumer behavior. Mm-hmm. We've been doing education and outreach for God knows how many years, since I was 5 years old, and we realized it doesn't work, right? If it did, we'd have much higher recycling rates. And so I think what the problem has always been, we just throw information at consumers. We keep thinking, well, if we educate them more. Mm-hmm. That's not the case, right? Who wants to learn more constantly? Yeah. Really, it needs to be about behaviors and what is easy. And I know that's like a simplified word, but like what is easy? How do they operate in their home? And no one person is the same, right? We're all different, how we interact. But there are groups that we can do this as. So we know there's kind of the low participation. Mm-hmm. We know that there's the great recyclers. Then we know there's like the middle recycler. So we're really focused on what are the interventions, what are the behavior tactics that we need to see those consumers start truly participating in the system. So that's kind of our big next focus area, and it's really important as part of all the EPR that has passed, because there is going to be education outreach dollars that are needed, and we don't want to waste those dollars, right? It's critical to make sure we're putting those into good use.
Well, one of the things we learned, I think, from Sarah in the conversation before lunch was that, you know, she's skeptical of education, and I'm really thinking about this from the standpoint of my son, who, you know, in going to high school, you could tell through certain indicators. They have these indicators for students who are in high school of whether you've actually attended class and you know, gotten your education. And not all the indicators were entirely positive there. And so what he seemed to prefer to do was to have fun. And Sarah reminded us that having fun is maybe the best educator. How can we have fun with recycling? Are there ways to make it fun, beautiful, you know, enriching to our lives?
Well, I don't know. I'm a recycling nerd, so that's not fair. I'm married.
You'll just recycle because it's fun.
Yes, I'm married to someone in this industry. It's our party trick. Yeah, I don't know. Yes, it's about fun and sometimes doing good, just like being very basic of like, man, I did the right thing just now. I know that's very oversimplification, but like that is fun.
Yeah.
And then there's other fun ways, right? If you really are a recycling nerd, how you set up your system in your home is fun. I am a process person, so I love to make sure we have the right bins in our bathrooms.
Yeah.
It kills me when I see my husband, who works in this industry, put things into the trash can because it came from the bathroom.
Exactly.
Yep.
Yes.
So I think having fun, right? We do things like quizzes and tests, but like that's all great, but what is it day to day? Like what is your lifestyle day to day, and how do we make sure we're fitting into that lifestyle?
Yeah. Well, I want to go to Hassan now because Hassan is working on something that's quite interesting, and you've got Oscar, and I love the name because, of course, you know, I grew up with Sesame Street and knowing what Oscar meant, but you are creating something that helps to make recycling fun, but also decipherable, because none of us can figure out, none of us know from city to city what we can put in our trash cans. My trash can upstairs has a lot more stuff in it than it would if I were in San Francisco. So tell us about what you're doing to make recycling both a lot easier and a little bit fun.
Yeah, for sure. So, I mean, some of the stuff that Sarah was sharing, as well as Recycling Partnership, have obviously seen the work around behavior change. But fundamentally what we do is we apply AI with behavioral science to change people's behavior at the bin. And you know, maybe people might get the reference, you know, Mark Rober, that a lot of your kids might watch on Disney or Netflix or Prime. He loves hiding the vegetables, and that's very, very important, because if you're trying to teach physics, if you're trying to teach very complex topics, you've got to hide the vegetables. And this is what has failed, unfortunately, in the climate, in the sustainability space, specifically circularity or recycling, is that we try to inundate the person with thousands of rules, and there's 9,000 different recycling rules across the US alone, and it is confusing. And so just going back to what Oscar does, Oscar is an AI that just, you know, plugs behind a very busy recycling bin, right? And it uses a screen, a camera, and it sees what people have in their hand and then deciphers where it should go. So it very simply breaks it down into, hey, this item belongs here, right? So that the person is not having to figure that out, and we only get it right about 27% of the time. So we don't want to take that chance. And then that's why everybody downstream doesn't want that material, because it's like, well, it's already badly contaminated. So now we're like fighting uphill, and commercial waste is just garbage then. We're losing compost, which, you know, 60 to 50% of our bin is made of compost. And so that's really the first point is you've got to make recycling or education around this fun. And, you know, if you're at a stadium and Taylor Swift is coming up, you got to engage with people around a trivia about Taylor Swift, and then sneak in or hide the vegetable off, hey, that bottle in your hand belongs in this bin. And that's where recycling accuracy at Oscar stations across 20 countries have gone to like from 18% to 91 to 98% accuracy.
Really.
So-
And that's probably because when people get it wrong, you deliver an electrical shock, don't you? Isn't that part of the...
So this was the most
technology? It's like
requested feature, that we shock the individual. We try to
it
control.
really helps. I mean, you know, it's
We built a bin that
aversion therapy. So
Yeah, no, it doesn't. Oscar doesn't shock or throw water at the person yet.
Not yet, so.
But
San Francisco, we could do that. Yeah.
yeah, we do partner with the city of San Francisco, but they don't do that. Oscar does get grouchy, right? So,
So that's, yeah,
so it does show a big X.
disapproval.
And what's interesting is the data that we've seen across 200 million people that engage.
Yeah.
Whenever we show the big X or Oscar says, "Whoops,
Yeah. Yeah.
if there's 2 or more people in front of the bin, the individual will reach back inside the bin
Wow.
and take the object out.
Wow.
And again, public shaming works. So
and make him happier. So
Yes.
I want to turn now to Greg Jansen, because Greg is a reality check for us. He runs Triton Group, he runs a MRF and separation facilities, and we just met a couple of weeks ago actually. But what an operation he has, and there is a pragmatism, I think, that we need to embrace for what will work, what we can make work in this system so that we can make rapid progress, because the environmental community and the public are not going to stand for a system that doesn't end up cleaning up waste from the oceans and getting plastic out of where it doesn't need to be. Can you give us a sense from your perspective of what do we need to make sure that we do so that the recycling system is able to pick up these materials and use them in the highest possible way?
Yeah, so I'm the guy that's not on the picture here, so I appreciate you inviting me up here. A couple of things. I think that we have to establish reality, and the reality is that the plastic recycling industry is in crisis. Okay, I've been in it. I've been focusing specifically on plastics for about 15 years now. I used to run MRFs and sold those to Republican Waste Management, and we're in crisis for I believe 2 main reasons that we really haven't grappled with. We are grappling with them, but we haven't gotten there yet. And one is that we are one of the cheapest places, the cheapest place in the world to make virgin resin, okay, because of the fracking revolution, which is phenomenal to generate energy independence, et cetera, but because of that cheap oil and natural gas and the explosion of petrochemical manufacturing capacity in the U.S., we're the cheapest place in the world to make virgin resin. Secondly, which has mitigated that problem, is that we can no longer export our challenging waste to China and to Asia. So you got all that waste being dumped back onto the market in the U.S., and now we are the cheapest place in the world to make virgin resin.
Yeah.
The traditional markets for plastic are converters and molders, and they have 100% optionality right now on whether they choose recycled resin or virgin resin. So if you're a molder and you're an engineer and your job is to run that plant as efficiently as possible, are you going to use recycle or are you going to use virgin? Especially if virgin is cheaper, you're going to use virgin. So we have seen our markets completely erode in some regards, all right?
And there's a bit of a panic in the recycling industry. I was at a conference a few months ago where, I mean, every recycling company I would talk to, it's like, well, we're hanging on by our fingernails in this marketplace.
And it's not just us, it's Europe as well. I mean, the plastic recycling industry in Europe is in crisis. So you got plants closing because, to the young lady's point that asked the question about the markets, I love EPR. I think EPR is fantastic. I think the liquidity that EPR injects into the market is fantastic, okay? And I love the fact that the Recycling Partnership is now focused on demand, but for years it was on collection, okay? So it's not a cart, it's not a chicken and egg.
Yeah.
Demand has to be there first. If I'm a farmer and somebody says, I want you to grow this crop, first question I'm asking is, great, where can I sell it? How much can I sell it for? Well, sometimes you can sell it, sometimes you can't. We got this other stuff that's better than yours, that's sometimes cheaper, that they're gonna use instead of your stuff. You're not gonna grow that crop. Okay, so we have to, EPR also has to stimulate demand.
Yeah.
okay? And sometimes recycled plastic, because plastic is such a genius material, it's highly engineered for that specific purpose. Once you mix it all up into the omelet that we call single stream recycling, you can't put it back into that original package. You need to find new sources, okay? So that's what our company did. Once we finally said, well, we can't sell this stuff, we developed our own product called a composite railroad tie. It's stronger than oak, reinforced with glass fiber, replaces wood railroad ties, all right? Hundreds of millions of pounds of demand, potential out there, but those railroad ties have to be sold.
Yeah.
Right. So so if you leave here, if you leave here with one thought, it's there has to be a place for the product to go, and it's got to be able to be done efficiently with markets. Right. When public policy, economic interest, and social consciousness align, then the world can change.
Yeah.
Right.
And I want to go back just a bit to this product that you have created, because tell us a little bit about those. It's not just a generic, what do we do with all this plastic? We can just shove it together and create this. But this is an incredible market, and a large market.
Yeah, so I mean, there's 20 million solid oak creosote-soaked railroad ties that get distributed across the United States every year. 20 million, all right? 14 million of those are in the accelerated decay zones, meaning that they are decaying faster than the railroads, the major railroads in the U.S. had them on the books for. Because, as Bill mentioned, Mother Nature does something great with wood. It's called decay. Well, so the real market for a lot of recycled plastic is replacing all those products, that legacy material that's made of wood that's supposed to be outside. So we take 80 to 100-year-old oak trees. We cut them down, we soak them in poison, and we spread them across the country to the tune of 20 million a year.
Yeah.
All right?
Yeah.
Our product and other people's product, and not just ours, but solves that problem, right? But it would help if there was some legislation that compelled the railroads to actually use that product, right?
And the nice thing about this dynamic is, we all know that plastic lasts for a long time, right? And so you might question, well, why are we using a product that lasts forever for a use that lasts for 5 minutes?
Exactly.
So if we can have a system in which we are using it for those 5 minutes and then using it for how many years do those
I mean, we don't know. It could last 75 or 100 years. I'm not sure. We say 50 plus years, whereas the wood ties that they're replacing are lasting for 15, right? So that's the question. Like, plastic is a genius material, but its very genius gives it an end-of-life challenge.
Yeah.
So how do we leverage that genius? How do we recycle that genius of plastics? And we can do it by replacing legacy materials like wood, steel, and concrete.
Yeah. How do you feel about the various different recycling technologies that are emerging, and how would they potentially affect your business? You've got mechanical recycling, you have chemical recycling, biological recycling, and you have kind of integrations of these.
Sure. Yeah. So I think that a massive part of this is embracing advanced chemical advanced recycling, as I call it. The stuff that Holli is doing at Eastman, the stuff that frankly that Exxon is doing with their cogeneration or their co-processing technology, the stuff that Altera is doing, where they're turning it back into oil. We are not going to mechanically recycle our way out of this problem, full stop. There's too much plastic. Not going to do it, not going to happen. I don't care if you replaced every railroad tie in the country with recycled plastic, we are not going to mechanically recycle our way out of this problem. So if we really want to solve this problem, obviously we have to reduce, but we also have to embrace chemical advanced recycling.
So it's a combination of that,
because there's a market absorption thing. It's not just that chemical advanced recycling can handle the crappy material. It can handle the material that the mechanical recycling market can't absorb. Even if it's really good material, which a lot of times it is. I just can only use so much.
Yeah.
So I don't want to be a downer, but the recycling industry is in crisis. But there are solutions that exist right now to really get us to the next level, but we have to stop fighting ourselves. Stop fighting virgin plastic, stop fighting ourselves, start competing against legacy materials where we can recycle the genius of plastics, and embrace chemical advanced recycling.
Beautiful. Nice.
Give guys like me markets so I can invest millions of dollars into the recycling market where I actually have a business that makes sense. And I don't have to rely on a war, a hurricane, or an ice storm to bump the price, because that's not a business strategy. That's gambling in a casino.
That's for sure. Yeah. Holly from Eastman Chemical, you know, the cool thing about chemistry that I didn't realize until I was in college. I took chemistry in high school. I didn't understand what the heck was going on with it. And I took, you know, biology as well. It was only when I got to college and I took an astronomy course that I realized, oh my God, you know, all the sciences are connected, you know. Universe blows up, that's physics. Pieces come together, that's chemistry. And then they keep coming together, and that's biology. And then life comes out, and that's us. And who knows what, you know, happens after that. I thought, wow, this is cool. Chemistry is a design science, and the capabilities of chemistry are extraordinary. You take the same basic materials, you know, the same atoms, the same protons and electrons come together in the atom. In different combinations, you get whole different qualities that emerge by nature. You combine those atoms together into molecules, and every molecule has its own personality that emerges, not predictable in the parts. And I thought, my gosh, we've been thinking of chemistry or chemicals as a derivative of a toxic process. And really what it is the expression of nature as it moves from the inert to the living. And look at all the capacities that we can have. Now, Eastman has carried this further than probably most any of the large chemical companies, creating some really interesting combinations of plastics with qualities. Tell us a little bit about Eastman's role in this, and how do you feel we can expand recycling and get to higher utilization of plastics and resins?
Thank you, Bill, and thank you for clarifying what the question was, because I thought if I was going to have to go deep into chemistry, I was going to have to leave the stage very quickly.
Yeah.
But anyway, I work for a company called Eastman, and we are based in Kingsport, Tennessee, and have a long history in working with polyester-based materials in particular. And in fact, like when you were talking about the development of the PET and the recycling industry, 1990s and before, Eastman as a material supplier was instrumental in that. It was really the material producers who came together to help us figure out how do we get these things back into the system. Mm-hmm. Well, we're innovating again. And the way we're looking at this now is instead of focusing exclusively on mechanical recycling, which is brilliant because there's a brilliant simplicity with plastics that allow you to essentially take materials that are the same, chop them up, wash them, remelt them, and make something new. Mm-hmm. It is a low carbon intensity, it's a low energy intensity, and it's a brilliant process. Now, what we've realized, though, is that not all materials fit neatly within that process. Mm-hmm. For example, if you have different colors, if you have different formulations, you may not be able to use those the same way. Mm-hmm. So the way that we're doing this at Eastman is a process called methanolysis. Okay, and that's for polyester-based or PET-based materials. And what we're doing is this gives us a chance to take the hard-to-recycle PET-based material and bring it back to essentially to its base components or its monomers, and from that be able to put them back together and make brand new materials that are indistinguishable from prime. Mm-hmm. So really exciting process, and we're really excited about how we can do this because this gives us a chance to be additive to the system. You know, Sarah can talk about this, Greg's talked about this. There are big challenges around getting all of the materials collected. Mm-hmm. Not all of the materials that are collected have a good home. And so for Eastman, focusing on colored and opaque PET packaging, mm-hmm. focusing on things like polyester-based carpet material, focusing on material that comes out of the textile industry. About 60% of your clothing is polyester-based. Mm-hmm. And looking at things like clamshells or thermoforms. If you think about your blueberry trays or some of those types of materials don't have good options. So by focusing on those, we're being additive to the system and giving us a chance to kind of reset the polymer and kind of reset the clock.
Yeah. And what do you feel like the system what needs to happen in the system so that Greg's needs and the recycling industry's needs are met, and we have a stream of plastic that's coming back in a form or multiple forms that can actually be used by an Eastman and others?
Yeah.
We need
So-
policies, we need markets, and who needs to act?
We need a lot. This is system change innovation, to be very clear. This isn't all of a sudden you just go and we built a plant and great, we're set now.
Yeah.
Okay, so what we're looking at is what are the changes that need to happen from a policy standpoint, from a system standpoint, from a market standpoint. A couple of the challenges that we're dealing with right now is there's a balance between designing packaging for recycling. And when you look at what those design guidelines look like today, they're designed for mechanical recycling, which is exactly what they should have been, but now we have new technology. So if we only rely on those, then we only create recycling options for materials that fit within the existing system that has already been here. So that's one of our challenges. Another challenge that we're dealing with right now is just system innovation. So for example, there are many communities that do not accept PET thermoforms. Sarah mentioned this, and this has been a very focused effort at the Recycling Partnership across a variety of organizations as we try to bring these materials in, because if there's not an end market, like Greg mentioned, nobody wants to collect something and then dispose of it.
Yeah.
So how do we ensure that there's an end market for that? But then how do you actually create organizations that can process or handle this material? One of the things that we've done and worked very closely with an organization called Reencle, and they are a regional MRF operator in the Midwest. They have a new facility in Columbus, Ohio, and what they have done is they have created what I like to call a bifurcated PET stream. So they are creating a stream of material that is optimized for a mechanical reclaimer, clear bottles only. Now the rest of the PET, thermoforms, colored and opaque, all of that is coming to Eastman. So it's a really exciting way to look at that a little bit differently. But here's the biggest underlying challenge that we have right now, and I'm gonna build a little bit on what Greg was sharing. We have an absolute decimation that is happening to the PET recycling industry in the US right now in particular. We have lost over a quarter of the percent of PET reclaimers in the US because they have gone out of business. And much of that is coming because material is being imported from overseas at prices that are not even close to the space where we could collect and handle and sort and prepare the material. And this has been an absolute travesty. And as many of you know, when you lose assets, they do not generally come back immediately. And so there's a big, big challenge that we have right now where we're looking at policy trying to make sure that we're protecting and supporting domestic manufacturing.
So driving demand, part of the demand drive is to make sure that we are keeping those facilities, and those facilities have a stream of revenue and income so that they can provide the demand and meet the supply. And that's going to take a combination probably of consumers, moms who are active and who care, brands that care, and suppliers. And it's going to be a team. It's going to be a group effort. Now, one of the most fun elements Joe is going to talk about here, and I have to admit that I am a consumer. I like to buy things. It gives me that little pump of whatever, cortisol or something? No, it's not cortisol. It's something else. Dopamine. Thank you. It's the dopamine, I guess. And one of the products that I am going to yield to and to buy is one that Joe is going to tell us about, and I think it meets the qualities of fun, beauty, and this kind of home improvement utility that is maybe a sweet spot in the marketplace. So tell us what you're up to.
Yeah, so we're into the composting of organic waste, and sitting on this panel and hearing about the travails and the difficulties of plastic makes me so happy that I do food waste because it is so simple. We do, but it is so simple. Yeah, it is fun. So we do electric composters that rely on microbial decomposition to decompose the food waste. So it's not like the dry and grind dehydrators that you see in the market. It's actually microbes that they're metabolizing and reproducing and eating the food. And we do them both in the home, we do them commercial, and they are fun. We, like ours at home, we named him Seymour. And Seymour gets fed when even my wife called me yesterday, Seymour stinks, what'd you do before you left? I'm like, oh, that was probably rotted milk. And some of our corporate clients in their facilities have actually decorated them, put on little mouths and antenna and stuff. So they make it a fun process with food waste. But the DNA in our company is basically we want to regenerate soil. We want healthy soil, and the best way to get healthy soil is organic material. And the easiest way we can do that is by utilizing our this most valuable resource that we have devalued for too long.
Yeah.
And that's our food waste. Another thing that's great about it is that people control the process. You can be completely circular at your home with food waste. There's a lot of things we can. I mean, I tried to be circular with my GI Joes when I was little, but you use fire to try to get the arm reconnected, and the plastic becomes brittle and it falls off again. So I couldn't reuse my. Yeah, they need the repair guys. I need the repair guys for that. But food waste, you control that. And we know that through a lot of studies of human behaviors, when people feel like they have control of something, they're more apt to change. And so being able to control that what comes into my home, what we consume, that food is a valuable resource that we can then reuse and use for planting right in my own home is really powerful. And so we're in 19 countries with 300,000 home units sold, and we've done about 40 commercial deployments in places like Universal Studios Orlando to Amazon in Seattle. So it's great to see people understanding like it really is simple and the impact is huge.
I'm going to buy one. And I think what's the consumer price for this now? It's
so about 500. Well, Earth Day today $429, but we
okay.
Yeah, so we have our prime model, and then we have a gravity model that does more capacity during the day.
Yeah.
What's great too is that our customer is very much a DIY customer. So we've intentionally, and we're based in Korea, and one of the things we found that the Korean customer, they don't want to fix anything. It's got to be brand new. If something happens, they want it gone and they want a brand new one. The U.S. customer, we have a growing community on Facebook of what we call our Reenclers. And probably 60% of our customer service in the U.S. is done by that group. They communicate if they have issues. They coach each other through it. We have master gardeners to people are just, throw it in their grass, right? You get a little bit of everything. But they help each other, and they expect that they can have access to parts and manuals and videos so they can fix their units. And so that's been a big mind shift, especially for our team in Korea, to say, oh, we need to make sure we build these modular so it's as easy as possible for people to fix. So all the designs that we've done now and in the future we continue to make improvements to allow people the easiest way to be able to fix them.
Great. So we're bringing all of our elements together here. We're bio recycling, and we are also making a product that can be easily adapted and fixed over time. So that sounds terrific. I would like to broaden the discussion here, and in particular, I want to call on Jamiel and Coco and Brenda Wise, if you're here, to join the conversation and either ask a question or make some comments. Bring some of the knowledge and resource that you have. Now I can't see a thing because I've got these bright lights, shining at me, so I don't see where you might be. But and then of course I'd love other people to comment as well. So please.
Bridging some of the conversation from the previous panel, we heard about how EPR is primarily focused on PCR and mechanical recycling. How do you all see bridging that gap and bringing chemical processing into that conversation and as a benefit to complete that system?
Okay, so really interesting question. One of the things that
Can you repeat the question a little bit? I couldn't quite hear.
So the question was really focused on how do you bridge the gap between pre-consumer or post-industrial material and most of the policies that are coming out that are focused on post-consumer material streams? Yeah. And so I think as we look at with the technology that Eastman is operating, we do have a mix of material that is pre-consumer and post-consumer. However, we also know that for our end markets and our customers who are interested in buying these materials, that they are more invested in post-consumer material. However, we don't want any material to go to the landfill unnecessarily, because those are essentially going to be wasted resources. So what we try to work with is, depending on different markets, different systems, there are different drivers for different industries in terms of what's most important to them. And so we just try to match those up, I think, in terms of the customers. Obviously, anytime you want to drive out as much waste as you can in manufacturing processes and reduce that so that you don't generate as much pre-consumer material, but the goal here always is to make sure that we're not sending valuable resources to the landfill.
So as a processor, the problems aren't quite as acute with pre-consumer because you have a very defined product, right? It could be trim. It hasn't been mixed with other material. So you kind of know what you have. And a lot of times that'll be the first recycled plastic that converters or molders will select, as opposed to post-consumer. So the product is a little more acute. The problem is a little more acute with post-consumer. For example, you know, if I'm trying to separate my polyethylene from my polypropylene and I've got 10% one in the other, that might make it unsellable in post-consumer, right? Pre-consumer, not so much. Now, I'm not involved in EPR policy, but I know that there's a very large debate, and Holli probably speak more of this, about mass balance, which is basically, the way I understand it is, you know, you cannot trace that molecule to its exact end use. It's kind of like putting a garden hose in the Mississippi River, right? I mean, eventually it's just gonna go into it. So what I like to think about it is, we're taking plastic and we are turning it back into oil. We are retaining that, you know, advanced chemical or chemical advanced recycling is retaining that molecule. What happens with it after that, I don't know, and I think that that's the debate on mass balance. I don't know if you want to speak more to that, Holli?
I guess I will talk about mass balance a little bit. Mass balance is one of the big concerns and the questions out there. Essentially, what we're dealing with in this situation is you have this mix of, let's say, virgin material, and in some cases, the material that has been developed or processed through recycling technology that then get mixed together. And then the challenge becomes is, how do you trace where those products those products actually go? So for Eastman's standpoint, the way we've been looking at this, and I want to be very clear too, with Eastman's technologies, we don't produce any fuels with our technology. Ours are going back into monomers and then actually goes back into materials. What we try to do, though, is leverage existing assets at the same time. If you guys remember from the session before, you know, if you think about continuous improvement, why replace an existing system if you already have one? And so where we've been focused is, how can we leverage our existing polymer manufacturing facilities that we have in Kingsport, Tennessee? And so we have essentially tank farms, where we store DMT or ethylene glycol. Those are those two monomers that we make out of the process. And in some cases, those become mixed together. But what we do is we track very carefully how much we are producing through our methanolysis process, and making sure that we are then applying those, essentially, those attributes to the right products at the end of their life based on what they're using. So some of it is a little bit of an accounting methodology that becomes very concerning, I think, to a lot of folks. And so trying to ensure that we have the right level of transparency and credibility on that system is absolutely essential. Nobody likes to think that valuable resources go into a black box and then all of a sudden magic comes out. It's also not generally believable. So how do we really cut through the confusion and the disbelief and add that transparency that we need?
And I think, you know, from mass balance perspective, and by the way, mass balance essentially refers to, and correct me if I'm wrong or imprecise on this, but when you see a product in a store that says 30% recycled content, that material probably comes from a source that was a mix of various inputs. 30% of those inputs may have been recycled, 70% may not have been recycled, And out of that comes a wide variety of materials. When you do mass balance, you essentially attribute the recycled portion to the recycled input. And it makes it much more feasible to use existing facilities and gradually shift them from primarily virgin sources to, a greater and greater percentage of recycled sources over time. If we were not to allow mass balance to be used, then we would have to build all new facilities for all new products, and that is extraordinarily resource intensive and would have a much greater environmental input or impact. So I think it's going to be necessary for us, in order to evolve this industry, to have mass balance as a standard policy in order to drive things up. Do folks?
And that's actually, and it's used across a variety of industries. I think where a lot of folks are bumping into mass balance for the first time is around discussions on plastics. And plastics have a special spotlight on them right now. And there are a lot of concerns around plastics. And as we think about this, mass balance is essential in the paper and fiber industry. It's essential in the aluminum industry, and it's essential in the glass industry. And so we need to be very careful as we think about what's important and how we use some of these mechanisms to be able to develop and scale up these technologies, leverage existing assets, but also understand that this is a much broader issue than just plastics.
So one of the areas that I think I'd like to challenge folks. Oh, Jamiel, let me turn to you.
Okay, so I'm Jamiel Hampton. I'm CEO of NAKA Industries. We're based in Japan, where waste is far more regulated than it is here in the States.
Yes, they are.
And they have their own EPR type programs that are in their regulations for how waste is handled and how it's used after the fact. So our buyers are specifically working under the ISCC Plus scheme. I'm not sure it's even here in the States yet, but their whole thing is about traceability and about, like you were saying, mass balance. And so they really want to focus on post-consumer, as you said, because the post-industrial, it's lovely because you get a homogeneous feedstock and you know exactly what you're going to get every time, but they want to focus on the post-consumer, and that puts you in the boat of having to deal with all types of mixed plastics. We are hoping to come here to the States, but until, programs like EPR are in place or waste is just more regulated, it's a little hard to operate in this space. And when your buyers only want a specific type of feedstock, then you can only go to where the demand is. So and I just think it's interesting that, like, I was on a call, I believe, about EPR about a month ago, and in California specifically, they look at chemical recycling as like a boogie monster, like there's something wrong with it. And like you said, there's no way to handle all of the plastic waste through mechanical means. I mean, it would be great, and honestly, I would send most plastics there first, but until we get to the point where we have layered infrastructure, like, it's just not possible. And so that's where we focus on the infrastructure part of it. We're looking to build circular infrastructure where we can recirculate those materials back into the market, and collaboration is the key. So it's got to be collaboration across the entire value chain. And so the plastics that you can't recycle, we can recycle, or Eastman can recycle. And since you guys focus most on polyester, right, and PET, so it's got to be layers. And just in my opinion, I don't know. It's not a question.
Which country do you operate in now?
Japan.
Japan.
Yes.
Any thoughts?
No, we buy a lot of our equipment from Europe, and I like this, and so it's being designed by engineers who have grown up with more of the European system where things are more source separated, and I can imagine it's kind of the way in Japan.
Yeah.
And I try to tell them, like, you have no idea. Like, you're dealing with an American waste stream here, right? Like,
Yes.
It's not like in Germany. It's not like it's in Denmark. And they typically will under-design the system for contamination and things like that, and so it doesn't last as long. So what we do here and the way we do it is very, very unique, and it really isn't the most recycling-friendly environment, right?
Please do not tell us to go back to source separate. Thank you. If anyone was going to ask that question.
We're going to do what we probably have.
Yeah.
Correct.
You know, I always look for the through line. Yes, I'll get to you in just a minute. Thank you. But I always look for the through line that brings all of the forces together, because we want with Circle America to have the broadest possible coalition. And I think what will satisfy folks is first we have to acknowledge the legitimacy of the concern on the part of many in the environmental community that we're going to take this giant mixture of crap that we call our solid waste stream, and we're going to do something to it that will gather some value out of it, you know, burn it or crisp it or chop it up and make it into parking, you know, barriers or something, and continue to create all the waste. And so I think the magic solution or the magic place where this all comes together is if we can have a very effective, intelligently designed system of source reduction that focuses on innovation, that, you know, generates new kinds of products and services that do more with less, so that we're reducing costs, but we're not imposing hardship on people. We're not imposing higher costs on consumers. We're also not limiting their ability to live their lives well. If we can do the source reduction part right, then people are going to be more accepting of the variety of recycling methods that are out there in the marketplace. So that's what I'm going to be looking for in the course of our work, and a lot of people in this room will be a part of it. Yes?
Yeah, thanks. It's funny you said Japan. I was just going to give the quote that 76% of plastic is recycled in Japan. They're the leaders. And 99.5% of aluminum is recycled in China. So we have a ways to go, but that shows us what's possible, right?
Mm-hmm, mm-hmm.
So I did a study for a German utility on the motivators and inhibitors around sustainability, and some of the things you've talked about relates to that. And so that's what I've been looking at, is how to deal with that, how to overcome that. And that's why I'm talking about something called eco campaigns and Rocket Ship Earth. Mm-hmm. And I would love to have recycling. You know, so the eco campaigns being, there can be challenges about, you know, the recycling of plastic and recycling of aluminum and you know, et cetera. I mean, a bunch of different challenges. But then also what's really important is it's got to be time bound. It's got to be that I see I'm part of a bigger picture. And the other part of it is the, like you said, the bins, you know, having the bins, you know, having a structure instead of it just being habit-based. So that's where bringing the products and the people together, you know, so there's also financial incentive to do it. So I think there's a lot of neat things, and I'd love to, I don't know which of you or all of you to talk to about setting that up for recycling, but we'd love to support you in doing that, in setting up campaigns that will drive recycling in a fun, like you say, fun way.
Yeah.
Exactly. Gamification. We're gamifying sustainability through reward and recognition. So love to work with you guys about that.
I want to emphasize that we are a community now. For those of us who choose to remain in the community, we're going to be having monthly calls, monthly get-togethers by Zoom to continue to advance the ball toward the goal and toward the multiple goals. And so this is not a one-time opportunity where we've got to make the partnership happen right now. We are in a group process that we're going to continue for those of you who want to. See, we have another comment. Yes, go for it.
Thank you. Hi, I'm Allie. I'm with TerraCycle. So
Yes.
we recycle hard to recycle products and packaging. So I can very much empathize with a lot of the challenges that have been raised. And to zoom in on packaging specifically, we're seeing, in general, manufacturers kind of go in three divergent directions, right? Some are switching to compostable or fiber packaging. Some are switching to, you know, recycle ready or like mono material packaging. And then some are just staying status quo, which might be, you know, multi-material, you know, packaging, everything from chip bags to, you know, our toothpaste tubes. Mm-hmm. So I'm curious across the board, because you all represent such different aspects of the value chain here, like how are all of these differences that are appearing on our store shelves? And it's very confusing for a consumer to know, is this wrapper, multi-material, mono-material, compostable? How is that impacting how you're thinking about collection and communication and the technologies that you're developing?
I was just going to say, we see this a lot because of the single-use compostables, and the question gets asked of us all the time, will this decompose in your unit? And then as we do food waste audits at different organizations, we'll go into a cafe and they'll say, well, everything here is compostable, like all the things. And then I collect all the samples of things that aren't compostable. And then the next call is showing them, no, this is plastic, this has a number on it, I don't know what it is, I can't even see it, right? So we're always talking about, we're worried of getting caught up into what's happened in the plastics recycling side, where nobody really believes it's going to go somewhere where it's going to be recycled, and nobody knows what a 1 is or an 8 is or not. They look at it and like, I don't know which one, right? So we've had a lot of conversations about that. How do we keep composting organic single-use compostables separate and simple, because it's starting to get this complexity. Oh, it's commercially compostable, it's home compostable, it's BPI certified, it's TUV certified. And so we're going to take, as a company, we're going to brand our own, so our customers will know if they buy all of our product, if it says Reencle on it, it'll be used in our devices. But that doesn't really solve the bigger problem of how do we make it simple for the consumer on these things. But I worry with some of the legislation things that want to go on in California, now they won't accept some of the compostables, that simplicity has to be key. And I think, anyway, I don't have the answer for how we do that yet, but it's something that we're very aware of. And a lot of the sustainability events that we go to, if you look in, I imagine my LinkedIn is full of pictures of garbage. I'm going to see bins here and every other sustainability event going on the country, and the bins are going to be full of contamination.
Yes.
They're all going to be mess.
Right,
So
right.
I can
Until
thank you
we
for
have
the setup.
Oscars every time.
But I know the conversation has been a lot around plastics and the process that happens post that. But the reality is there's a lot of materials and a lot of innovation that's happening, right? From compostables to, there's new, from a compostable side, seaweed-based things that are being produced, and there's just so much amazing innovation. That is the point, is reduction, change of materials. And so when you look at the system that is being built right now, we whether it's mechanical recycling or whether it's anything else, we have nothing to communicate to the consumer. And I think everything that we talk about, I've been in the industry for more than a decade now, and everybody keeps on, specifically in the waste industry, focused on the processes, focused on the back end, but never the consumer or the brand. Like, things start from the brand side that obviously they are trying to grow, right? People vote every day, buy their products, and love the experiences. And there's that byproduct that gets created. And consumer, us, we take that material and we don't have a second to scan that QR code with an app and with certain things to make a decision over there. And so that's really where, at the busiest areas like a mall, like an airport, like the local library, that is where we are creating this communication engagement consumer platform that figures the changing rules, right? Even in an aquarium, right? They've got compostable materials for a couple months. A year later, you've got a different vendor there, and they've changed it up, right? And EPR coming in, certain folks have changed something else. How does that trickle down to the consumer? Right? If we want to chemically recycle it, you need that certain material, because we cannot process and give Holly a bunch of crap, right? She needs a certain feedstock, and so does anybody that is innovating. So I think that's really where we focus in developing technology that changes behavior, that communicates and is effective. And I think the biggest learning is you can't be preaching by guilt guilt tripping people
Yeah.
and like, hey, here's a massive problem, and look, there's no. The biggest thing is there's no belief in consumers. Whatever we're innovating on in terms of materials, in terms of what is happening in the back end, people have no idea,
Yeah.
and there's zero belief.
If you guilt trip people, then either they are going to just feel guilty but keep doing the behavior, or they will go blank and not think about it anymore, or they will become part of the vocal opposition and deny that there's a problem because they don't like the solution that's being imposed on them. So we really need to work within what consumers will find acceptable and desirable. One of the aspects of a circular economy that I think is most interesting and most potentially consequential is the cultural side, which we're going to talk about in a few minutes. We have grown up in an industrial culture that is focused on the mass production and mass consumption of an enormous quantity of materials. And an industrial economy is an economy that tends to separate people. And I don't denigrate it at all, because first of all, I think it's quite a natural process to go through. You see nature doing the same thing. But I do think that it's something that we graduate from gradually. And so in an industrial system, we become more like each other. We have lifestyles that are more like one another's lifestyles. Our jobs are more like other jobs. They're more interchangeable, not completely, but somewhat interchangeable. Our family styles are the same. A lot of the diversity that is embedded in the individual is kind of, paved over, if you will, so that we can get along in an industrial culture. But now, with the advent of digital technology, and as we reach the limits of that industrial growth, we have the opportunity and really the necessity to move from a culture where a sense of meaning and purpose is somehow attached to how much stuff we have and buy and how big that stuff is, to an economy and a culture where it's our differences that give us a sense of satisfaction and how we fit together as a community. And so that's what we're going to talk about after the break, which is starting right now, right, Doozy? And
yes, so we're going to give you a maybe 15-minute break. Please come back. We have a lot of exciting programming left, including the panel Bill was just discussing about creating a circular culture, and then Maury Giles from Braver Angels and Shia Bastida. So come back in 15 minutes.
And these are extraordinary people that you're going to be meeting later on this afternoon. Not that these folks have not been. So thank you to our panel. Thank you to all of you.